Alright, number 5. The twice differentiable functions f and g are defined for all real numbers x. Values of f, f prime, g, and g prime for various values of x are given in the table above. First of all, before we get started on this problem, so it doesn't seem too scary to you, this is just a chart of values. It's no different than making an f prime chart or a g prime chart. It's just given in word form instead of a chart form. So part A, it says to find the x-coordinate of each relative minimum of f on the interval -2 to 3. Justify your answers. Well, if I'm looking for a relative minimum, I would like to make an f prime chart. So my f prime chart, I'm going to look for where f prime is equal to 0. So I'm going to go to my f prime. It equals 0 at -1 and at 1. Okay, before -1, it tells me that f prime is negative. Between -1 and 1, it tells me that f prime is negative. And after 1, it tells me that f prime is positive. So if I'm looking for a relative minimum, it's going to be happening at x equals 1. And that will be because f prime changes from negative to positive. Okay, that part will be worth 1 point. You have to have the answer and the justification to earn your point. All right, part B, explain why there must be a value c between -1 and 1 such that the second derivative is equal to 0. There are actually a couple approaches that you can take for this one. I'm going to take, there's a mean value theorem approach, and then there's an Rolle's theorem approach. And really either one I think would be equally fine. I'm going to start with the mean value theorem. So if you use the mean value theorem, we know the conditions of the mean value theorem. If f is continuous and f is differentiable, then there must be some point where the average rate of change, where the slope is equal to the derivative. So those are actually my steps. So what I'm going to try to do on this, since f is continuous, and actually we're talking about f double prime, so we're going to up these, so f prime is continuous and f prime is differentiable. So f prime is continuous because it tells me that my function is twice differentiable. If it can't be differentiable if it's not continuous. So the conditions of the mean value theorem are met, which means there's somewhere where the slope has to equal the derivative. And if you look at the slope between, so I'm going to find the slope from -1 to 1. So I'm going to find, if I do f prime of 1 minus f prime of -1 over 1 minus -1, let's see what we get. We're hoping we're going to get 0, because then we could say that the mean value theorem holds for this one. So f prime of 1 is 0. Minus f prime of -1 is 0, so we get 0 over 2, which is just 0. So since we found that the slope was equal to 0, we also know that the derivative also has to equal 0. So I'm going to say, according to the mean value theorem, since f prime is continuous and differentiable, and how do I want to say this, and the slope or average rate of change or whatever between f prime of 1 and f prime of -1 is 0, then f prime of c must equal 0 somewhere for some c between -1 and 1. Okay, so that works. Okay, Rolle's theorem, you could actually also, there are conditions of Rolle's theorem. Same thing, f prime is continuous, f prime is differentiable, and then f double prime, f prime of -1 would equal f prime of 1, and actually that holds true as well. So we could say, I'm just going to say this, according to Rolle's theorem, since f prime is continuous and f prime is differentiable and f prime of -1 is equal to f prime of 1, according to Rolle's theorem, there has to be some time where the second derivative is equal to 0. So that would be another way of doing it. This was worth 2 points. Somewhere on your paper you had to have done either this or this. Okay, if you did one of those two and you found that average rate of change, you're going to equal 1. And then if you either spoke about the mean value theorem or Rolle's theorem, you'd get your second point. So that was worth 2 points. All right, part C. The function h is defined by h of x equals ln of f of x. Find h prime of 3. Show the computations that lead to your answer. All right, this is a very popular type of problem. We see parentheses. We're going to make this u because we need to find the derivative. So u is equal to f of x, which would mean du is going to equal f prime of x. All right, so let's find the derivative. So the derivative of h, the derivative of ln u, if you remember, is just du over u. So it's going to be du over u, and then that will equal, in this case, du was f prime of x, and then u is just f of x. So if I want to find h prime of 3, we're going to do f prime of 3 divided by f of 3. So f prime of 3, hopefully they told me what that was. They did. It's 1/2. So this will be 1/2 divided by f of 3, which they nicely gave me that as well. So 1/2 divided by the 7 is the same thing as 1/2 times 1/7, and that answer is 1/14. And we would get 3 points for this answer. We get 2 points just for finding that derivative. Good for us. And so give yourself a point for each mistake. Take off a point for each mistake you might have made, and then getting that answer was worth a point as well. All right, part D. Evaluate the integral from -2 to 3 of f prime of g of x times g prime of x. Okay, this just looks like a lot of messiness going on, but I'm going to do a u substitution right here. I'm going to let u equal g of x, which means du would equal g prime of x dx. So notice I have that sitting in my problem. So I'm going to set this up. This is going to be f prime of u, and then all of this stuff turns into du. Okay, so when I take the integral of this, the integral of f prime is just going to be f, and then the integral of du, we know those two just cancel each other out. So I have f of u. I still need to, now I'm going to plug back in my u. My u was g of x, so it's going to be f of g of x, and now I still need to evaluate it at the endpoints. They gave me -2 and 3. So this will be f of g of 3 minus f of g of -2. Now it's just going to be looking stuff up. So g of 3, if I look it up in my chart, is equal to 1. So now this will be f of 1 minus f of g of -2. If I look up g of -2 in my chart, that's equal to -1. So now this is going to be f of 1. So if I look up f of 1 in my chart, it's equal to 2 minus f of -1. If I look that up into my chart, it's equal to 8. So my final answer will be -6. All right, this was worth 3 points as well. If we did this whole step right here leading us up to getting an answer, that's going to be worth 2 points, and then 1 point for the correct answer.